Okay. So let's continue with this. Just give me a second. Yeah. So good afternoon, one and all, to all of you. So let's go ahead with aldehydes, ketones, and carboxylic acids. So we are discussing the chemical reactions of this particular aldehyde and ketone, right? So right now we are in the fourth reaction, which is reactions due to acidity of alpha hydrogen. Okay. And yesterday we have discussed one reaction under this topic, which is called as iodoform reaction. All right. So today we are going to discuss the second subdivision of this, which is called as aldol condensation. So aldol condensation reaction is very, very important. Okay. Aldol condensation is very important. So I will tell you what is aldol condensation. So you have to take 2 moles of aldehyde. Okay, you have to take 2 moles of aldehyde, which has alpha hydrogen. What is an alpha hydrogen? The carbon which is attached next to the C double bond is called as alpha carbon, and the hydrogens which are attached to the alpha carbon are called as alpha hydrogens. Okay, so you have to take 2 molecules of the aldehyde or ketone which has alpha hydrogen. Okay, and then you have to treat that with sodium hydroxide or potassium hydroxide. They are actually, okay, you have to treat it with the base, any one of these base. So we will get aldol, and then on heating this aldol, we will get a compound, alpha beta unsaturated carbonyl compound. So this is the final product we get from the aldol condensation. Okay, but this looks somewhat difficult, right? So I will give you a trick to get the direct aldol condensation product. Okay, I will give you a trick to get the aldol condensation product directly. So first what you do, draw the 2 molecules like this. Okay, draw the 2 molecules of aldehyde or ketone like this. Okay, so here you see we have our CH2CH, and this is our CH2CH. So now what you have to do, remove oxygen from one molecule and 2 hydrogen from other molecule. 2 alpha hydrogen from the other molecule. So what we are doing, we are removing the H2O. Okay, we are removing the water molecule. So oxygen from one molecule and the 2 alpha hydrogens from the other molecule. Okay, just remove this H2O and connect the molecules. So this particular carbon, the C double bond, this carbon will be connected to this one. Okay, and it will give us the final product. So you see here, RCH2, C double bond C, R, we have a CHO. So this is the final product. So this is the final product. This is the aldol condensation product. Okay. 2 oxygen and 2 alpha hydrogens. That's all. Clear? So is it easy for all of you? Is it easy for you guys? You can take any base. Potassium hydroxide, sodium hydroxide, and barium hydroxide. Any one strong base you can take and do the reaction. Okay. So without forming the intermediate, if you want to get the final product immediately, so do the trick which I have taught. Suppose if I have CH3C double bond OH and CH3C double bond OH. What I have to do? I have to remove oxygen from one molecule and 2 alpha hydrogens from the other molecule. So these are the alpha hydrogen. So there are 3 hydrogens. So remove 2 hydrogens alone. So remove 2 alpha hydrogens alone and write the product. What will be the product? We will have CH3 and we have CH. So there is a double bond at the top. I'll write the double bond here. Okay. So double bond, and here we have CH, and it is attached with C double bond OH. Okay, this is the final product. Is it clear to all of you now? Any doubt from aldol condensation? Do you guys have any doubt from aldol condensation? Shall we solve one question, one previous year question from this topic? Harish, you have joined late today or what? See, we are discussing about the aldol condensation. We are discussing about aldol condensation. To get the aldol condensation product, we have to take 2 molecules of aldehyde or 2 molecules of ketone. Okay. And treat it with the due to current cut. Okay, no problem. Just listen now. So take the 2 molecules and treat it with the base and heat it. That will give you alpha beta unsaturated carbonyl compound. Okay. So now, and I have taught one trick to find out the product. So in that trick, what I have said is write the 2 molecules like this. Remove oxygen from one molecule and 2 alpha hydrogens from the other molecule. So we are removing the water molecule from these 2 species and getting the final product. And this is the example I gave. Okay. So oxygen is getting removed from one molecule and 2 alpha hydrogens are getting removed from the other molecule to give the final product. So is it clear? Shall we solve a question? Students, are you all ready? Guys, please do give me a reply so that I can understand. Madhukar Reddy, Parveen, Rahul. Any doubt? Any doubt? Okay. So this is the question. Consider the given reaction. Consider the given reaction. So we have CH3, COCH3. It is treated with diluted barium hydroxide and it is giving X. The functional groups present in compound X are. So how to find out? So barium hydroxide is a base and we have a ketone. CH3COCH3 is a ketone. So what we have to do to get the final product? Take 2 molecules of CH3COCH3. This is the first molecule and this is the second molecule. Okay. So now what we have to do? Remove oxygen from the first molecule and 2 alpha hydrogens from the second molecule. Here both of them are alpha carbon. So we have 6 alpha hydrogen. You can remove any 2. Okay. So I am removing the oxygen from first molecule and the 2 alpha hydrogens from the second molecule. So what will I get? CH3, C, CH3, double bond. So I have removed the oxygen. So there I have to connect this. So I have CH, C double bond O and CH3. So this is the final product. This is the final product X. Okay, now we have to find out the functional groups present in this compound. So can you guys find out the functional groups? What are the functional groups present in this compound? Can you try for it? Can anyone find out the functional groups present in compound X? Yes or no? Option A. Okay. So we have a ketone and a double bond, right? Exactly correct. So C double bond O. Here also we have an R group. Here also we have an R group. So it is a ketone. RCO, R is called as ketone. And this is a double bond. Double bond is also a functional group, right? So option A is the correct answer for this question. Okay. So we are getting this product by doing aldol condensation. All right. So now let's enter into the cross aldol condensation. Now, what is the difference between aldol condensation and cross aldol condensation? In aldol condensation, the 2 molecules which we are taking are same. The 2 molecules which we are taking are same. Okay. But in cross aldol condensation, one molecule will be different from the other. Okay. One molecule will be different from the other. So when aldol condensation is carried out between 2 different aldehydes or ketones, it is called cross aldol condensation. Okay, between 2 different aldehydes or ketones. So if both of them contains alpha hydrogen, We are taking two molecules, right? If both the molecules contains alpha hydrogen, then that particular combination will give four products. That particular combination will give four products. I will show you. Let me take two different aldehydes, okay? So these are the two different aldehydes. One aldehyde has 2 carbon and the other aldehyde has 3 carbon. So these two are the two different aldehydes. So now it is treated with the base sodium hydroxide and it is heated up. Now this combination will give four products. Okay. The first combination is one molecule of CH3CHO will react with another molecule of CH3CHO. Means in the container, we will have more number of CH3CHO and CH3CH2CHO. Okay, this is ethanol and this is propanol. So we don't have only one molecule of ethanol and one molecule of propanol in the mixture. We have more number of molecules in the mixture. So I may have 10 molecules of ethanol and 10 molecules of propanol, for example. So the one molecule of ethanol will react with another molecule of ethanol will give one product. Okay. Listen. So one molecule of ethanol will react with another molecule of ethanol and they will give rise to one product and this is the product. Okay, this is the product. And the second combination is one propanol will react with another propanol to give the second product. One propanol will react with another propanol to give the second product. You all know how to find out the product, right? Suppose propanol means CH3, CH2, C double bond O H. This is the first molecule of propanol, CH3, CH2, CHO. This is the second molecule of propanol. So remove the oxygen from one molecule and the alpha hydrogen. So this is the alpha hydrogen, right? So this is C double bond O and this is alpha carbon, this is beta carbon. So you have to remove the alpha hydrogen. So if you remove the H2O like this, what will you get? So we have CH3, CH2 and CH double bond C. Okay, so here we are taking the hydrogen from this carbon, right? So we have C and that C is attached with CH3 and this side we have a CHO. So this is the final product we are getting here. Okay, CH3, CH2, CH. This is that component. Double bond C, and that C is attached with CH3 and that C is also attached with CHO. Clear for all of you? You don't have to memorize, just understand and write in the way you have understood. Okay, you will get the correct answer. You will get the correct answer if you follow this trick. Okay. So what I was saying, I said that 4 different products will form from this. The first product is the combination of ethanol and ethanol. The second is the combination of propanol and propanol. So do you guys have any doubt from this? Any doubt so far for anyone? Shall I go for the third combination? Shall I go for the third combination? Okay. So let me erase the things that I have on the slide. Yeah. Now I'll go for the third combination. Before going on to the third combination, I would like to give the name of these two products. These two products are called as self-condensation product. Why it is called as self-condensation? Because the combining molecules are same. Okay, ethanol, ethanol, propanol, propanol. So it is called as self-condensation product. Okay, so now the third combination. Third combination is one ethanol and propanol. Okay, you have to remove oxygen from one compound. For example, you can remove oxygen from ethanol and you can remove the alpha hydrogen from propanol. So this will give rise to one product, third product. And if you remove the oxygen from propanol and hydrogen from ethanol, that will give you the fourth product. Okay. So since we are taking different combination, it is called as cross condensation product. is called as cross condensation product. Okay. So we are getting 4 products like this. In case of this cross aldol condensation, if you see, self-condensation products are formed in the major quantity. Okay, this is the important point that you have to note down. Self-condensation products are formed in the major quantity compared to cross-condensation product. Clear? Is it clear to all of you? Any doubt? Any doubt for anyone? Will you all be able to find out the 4 products if I give some other 2 different types of aldehydes or ketones? No doubt for Rahul. Okay, that's great. That's great. Very good. Good. So we are ending up with the 4th type of reaction, 4th classification under chemical properties, which is reactions due to alpha hydrogen. Okay. So now we are entering into the 5th reaction, 5th chemical property or 5th chemical reaction of aldehyde and ketone called Cannizzaro reaction. So what is Cannizzaro reaction? In which type of reactant it will react? So Cannizzaro reactions involves aldehydes having no alpha hydrogen. Cannizzaro reaction involves aldehydes having no alpha hydrogen. So can anyone give me one example for the aldehyde which has no alpha hydrogen? Can you give me one example which doesn't have alpha hydrogen? Can anyone give me an example of a compound which doesn't have alpha hydrogen? Can you think of it? No, we are discussing about aldehydes, right? So, Parveen, you cannot go for acid. Formic acid also doesn't have alpha hydrogen. But since we are discussing about aldehydes here, you can say formaldehyde. So, Deva has given the correct answer. HCHO. Parveen answer is also correct. Okay, formic acid also doesn't have alpha hydrogen. But here we are discussing about the reactions of aldehydes and ketones. So, it is better if you go for formaldehyde, which is HCHO, which is also called as methanol. Okay, Harish answer is also correct. So the formula for methanol or the formula for formaldehyde is HCHO. HCHO. Okay. So here, 2 molecules of the compound which doesn't have alpha hydrogen will be taken and it is treated with the base NaOH or KOH. So among those 2 molecules, one molecule is getting reduced to alcohol and the other molecule is getting oxidized to acid, carboxylic acid. Okay. So if we reduce the aldehyde, we will get alcohol. If we oxidize the aldehyde, we will get carboxylic acid. Okay. So one compound will be reduced and the other compound will get oxidized. Clear? So let me give you the reaction again. And the Cannizzaro reaction involves different aldehydes having no alpha hydrogen. Then this reaction is called as cross Cannizzaro reaction. If a reaction involves different aldehydes, then it is called as cross Cannizzaro. So what is the difference between Cannizzaro and cross Cannizzaro? So for example, let me take one example for Cannizzaro. So as you have said, formaldehyde as an example, let me take 2 molecules of formaldehyde, HCOH and HCOH. Okay. So one of the formaldehyde on treatment with sodium hydroxide or potassium hydroxide will be converted to alcohol. Since we have only 1 carbon here, we will get a 1 carbon containing alcohol called as methanol. Okay. This is the reduced product. Alcohol is the reduced product. So the other one will be the oxidized product. Okay. So 1 carbon containing acid is called as HCOH. What is this? This is called as carboxylic acid, and the name is methanoic acid. The name of this compound is methanoic acid. So one carbon containing alcohol and one carbon containing carboxylic acid is formed from the formaldehyde, okay, from methanol. So since two compounds that we are taking are same, it is called as canisol. If you are taking two different aldehydes, which doesn't have alpha hydrogen, two different means one can be HCHO. What could be the other compound? Can anyone guess? The second compound which doesn't have alpha hydrogen? Can you give another example for the compound which doesn't have alpha hydrogen? Can you think of it? Can anyone think of the other compound which doesn't have alpha hydrogen? It can be an aromatic aldehyde also. I hope you can get the answer by now. It's very easy. The very familiar aromatic aldehyde you all know. Has anyone? Yeah, very good. Very good, Rahul. Ganesh. It is benzaldehyde. It is benzaldehyde. So benzaldehyde also doesn't have alpha hydrogen, right? C6, H5, C double bond OH. So this is C double bond O and this is the alpha carbon. And it already has four bonds. So there is no alpha hydrogens present in benzaldehyde. So I can take one molecule of benzaldehyde and another molecule of methanol. Okay, or formaldehyde. And if I treat it with a base, the aromatic aldehyde is getting reduced to alcohol. It is getting reduced to alcohol. And the formaldehyde, HCHO, is getting oxidized to carboxylic acid. It is getting oxidized to carboxylic acid. Okay. So now, how can we convert the aromatic aldehyde to alcohol? Won't it get oxidized? Won't the aromatic aldehyde get oxidized? So it has to be get reduced or it can get oxidized also. Any idea do you guys have? Why the aromatic aldehyde is getting reduced instead of getting oxidized? Is there any condition you know? Any idea for anyone? Can I form benzoic acid and methanol? Can I form benzoic acid and methanol? So if I oxidize this aromatic aldehyde, I will get benzoic acid, right? And if I oxidize the methanol, I will get methanol, CH3OH. So this is the reduced product and this is the oxidized product. Can this combination be formed? What is your opinion? Or only the benzyl alcohol and the methanoic acid? Say yes or no. Just say yes or no. I won't ask you why you have said yes or no. No. Aishwarya's answer is correct. I will give the reason for it. Okay. So the second combination, this benzoic acid methanol combination is incorrect. Okay. Why it is incorrect and what we have to follow? Usually, the less hindered aldehyde will give the oxidized product. Less hindered means less crowded. Less crowded aldehyde will give the oxidized product. Okay, less crowded means the small molecule. So, one carbon containing aldehyde is the small molecule, right? So, that's why it is getting oxidized to acid. Okay, the other one, the benzaldehyde, is getting reduced to alcohol. Clear for all of you? Able to understand Canizero and cross Canizero? So Canizero reaction, takes place in the aldehydes which doesn't have alpha hydrogen. So there also we have two types. One is normal Canizero in which two same reactants involve, and the other one is crossed Canizero in which two different aldehydes will involve. Okay, if you are taking two different aldehyde, then the oxidized product will be formed from the compound or from the aldehyde which is less crowded or less hindered. All right. These are the points you have to keep in mind. Shall we go for the next reaction? Shall we go for the next reaction? Any doubt from Canizero? Any doubt from Canizero? Shall we go for the sixth reaction? Guys, can we go ahead? I'm waiting for your reply. Can we go ahead? Yes or no? Yes. Fine. The sixth reaction is electrophilic aromatic substitution reaction. So you all might be aware of this, right? We are learning this reaction from 11th class onwards in all the organic chemistry lesson. In 12th standard also we have studied this in haloalkanes, haloarenes lesson, and in the phenols part also we have discussed, right? In ethers also we have discussed, and now we are going to study this in the aldehyde. So the aromatic aldehyde is benzaldehyde. We are going to do the electrophilic substitution in this aromatic aldehyde. Okay. So there are 5 types of electrophilic aromatic substitution. The one which I'm going to take here is the halogenation. Okay. So in the halogenation, let me take bromine halogen and I'm treating it with FeBr3. So Br2 in presence of FeBr3 is the halogenating mixture. This is the electrophilic reagent, and from this we will get Br plus electrophile. Okay, so that Br plus electrophile will go to one of the position in the phenyl ring. So can anyone tell me to which position it goes and attacks? Ortho, para or meta? What is your answer? Which position it will go and get attached? Will it go to the ortho, para position or meta position? Will it go to ortho, para position or meta position? Just give it a try. Ortho, para you're saying? The answer is no. Okay. So far, we have discussed about the reactant or the phenyl ring which carries the electron donating group. Okay. So we have discussed the compound which has electron donating group. For example, in case of phenol, we had OH. OH is an electron donating group. Okay. And in case of ether, we had OCH3, alkoxy, which is also an electron donating group. Okay. In case of haloarene, we had Cl. Cl is an electron donating group again. So, in case of electron donating groups attached to the ring, the incoming electrophile will go to ortho position and para position. So, we got two products, ortho product and para product for all these types of reactants. Okay. But now, we have CHO attached to the ring. So CHO is an electron withdrawing group. CHO is an electron withdrawing group. So the incoming electrophile will go to the meta position. Incoming electrophile will go to the meta position. Okay? Clear? So if electron donating groups are present on the ring, the electrophile will go to ortho position and para position. If electron withdrawing group is present on the ring, then it will go to the meta position. You may ask me, ma'am, how do I know whether this group is electron donating or electron withdrawing? We already have studied the list of electron donating and electron withdrawing groups in class 11 as well as in class 12. Okay. So alkyl, alkoxy, alcohol, ether. Okay. So ether only will come here. And amine, NH2. So all these groups are electron donating groups. Electron donating groups. Electron withdrawing groups are aldehyde, okay, carboxylic acid, and amides. So all these will fall under electron withdrawing group category. So in all those cases, the electrophile will go to meta position. So is it clear now for all of you? Do you have any doubt? These are ortho-para directing groups and these are meta directing groups. Clear? Students, any doubt? For Deva, it is clear. What about others? You guys are confident, right? Enough in the topic now? Yes. Okay. Great. Clear. Fine. So we are ending the chemical reactions here. So we have discussed the 6 types of chemical reactions of aldehydes and ketones, and this is the last reaction. Okay. So I hope all the reactions are crystal clear to all of you. So if you have any doubts, if you're getting any doubts while revising or solving some problems, you can take those doubts to me and you can ask. Feel free to ask. Okay, so all the reactions which we have studied are very important. All right. So now let me move on to the next topic, which is the last topic of aldehydes and ketones. We did not enter into the carboxylic acid yet. So this is the last topic of aldehydes and ketones. We are going to discuss about the uses. Okay. So mainly aldehydes and ketones are used as solvents. They are used as solvent and for biological specimen preservative. Formaldehyde and all, if you see, they use for the preservation purpose of this biological specimen. In you can see. Okay. And thirdly, it is used to prepare bakelite. All of you can able to see the buttons, right? The bakelite. Bakelite is also there in the cooker handle. All of you can able to recall the structure of cooker, right? I hope it is there in all of your homes. So the cooker handle is there, no? The black color. So that is bakelite actually. It is a polymer. So it is prepared. It is aldehydes and ketones are used to prepare that bakelite compound, bakelite polymer. Okay. And also it is used in the urea formaldehyde glues. Okay. For the urea formaldehyde glues, it is one of the component there. So it is used one of the component in preparing the glues. So not only this, to be more specific, acetaldehyde is used primarily as a starting material in the manufacture of many compounds. So what is the formula for acetaldehyde? CH3CHO. Okay, CH3CHO is called as acetaldehyde. So this is acting as a starting material for the manufacture of many compounds. Some of those compounds are acetic acid, ethyl acetate, vinyl acetate, polymers, and drugs. Okay. So acetaldehyde is mainly used for the preparation of all these compounds. Is it clear for all of you? Shall I go for the next use? So if you take acetaldehyde and oxidize it, you will get acetic acid. Okay. Likewise, by doing the other reactions, we can able to form the other 4 compounds starting from acetaldehyde. Okay. So the next use, the next compound is about benzaldehyde. Benzaldehyde is also used, benzaldehyde is an aromatic aldehyde, right? So it is used for the preparation of perfumes. So it is used in the perfumery industries. Benzaldehyde is used in the perfumery industries and in dye industries also. Dye you all know, right? For making colors. So benzaldehyde is used in the dye industry also. And many aldehydes and ketones like butyraldehyde, vanillin, acetophenone, camphor, all these are well known for their odors and flavors. So they are all used in the corresponding perfumery industries. Okay, clear? Shall I summarize? Do you guys have any doubt? So let me summarize. Let me summarize from the fourth chemical reaction. Okay. So under the reactions due to acidity, we have studied about iodoform in the last class. And today we have started with the aldol condensation, and you know how to find out an aldol product, right? So don't forget the trick. And later on we have entered into the fifth reaction, which is Cannizzaro reaction, where two aldehydes which doesn't have alpha hydrogen takes place. And the last sixth reaction is electrophilic aromatic substitution, in which the phenyl ring attached to CHO will give the meta substituted product. Okay, clear? So with this, we are completing the aldehydes and ketones part of this lesson. Now the next is the carboxylic acid part. Okay, carboxylic, the preparation and properties of carboxylic acids. So first we are going to discuss about the preparation, then physical property, and then chemical properties of carboxylic acids. Okay, so let me enter into the preparation of carboxylic acid first. We have 4 to 5 preparations. All of them are very easy and which you will be knowing before. So let me start with the primary alcohols and aldehydes. So how will we get the carboxylic acid from alcohol and aldehyde? How will we get the carboxylic acid from alcohol and aldehyde? Do we need to oxidize or do we need to reduce? How will you get carboxylic acid from alcohol and aldehyde? By oxidation or by reduction? Yes, very good. If we oxidize an alcohol or if we oxidize the aldehyde, we will get the carboxylic acid. So we have to use the oxidizing agents, right? So the very first important oxidizing agent is potassium permanganate in basic medium. Okay. And the second one is potassium dichromate in acidic medium. The third reagent is CrO3 in presence of H+, which is called as Jones reagent. CrO3 in presence of H+ is called as Jones reagent. Okay. So let me show you the reaction. So take an alcohol, primary alcohol, RCH2OH is called as primary alcohol. And use one of the oxidizing agent, you will get an acid. Carboxylic acid will be formed. Not only with alcohol, you can use aldehydes also. RCHO is an aldehyde. If you treat it with the oxidizing agent, it will produce acid. Okay. So these two are the general reactions. I will give you some examples also. So let me take one alcohol, CH3, CH2OH. So what is the name of this alcohol? Ethanol. This is ethanol. So ethanol on oxidation will give ethanal. Ethanol on oxidation will give ethanal. This is not ethanol. It is ethanal. Okay. Ethanal will be formed. Aldehyde. So 2 carbon containing alcohol will produce 2 carbon containing aldehyde. Then if you still oxidize it, you will get a 2 carbon containing carboxylic acid. And this carboxylic acid is called as ethanoic acid. Ethanoic acid. Okay. So this is how we prepare the carboxylic acid from alcohols and aldehydes. Okay. Carboxylic acids are also prepared from mild oxidizing agents like tolerance reagent or filling solution. We have already discussed about these two tests, right, in the previous class. The carboxylic acids are also prepared from aldehydes by the usage of mild oxidizing agents like these two. So what are these then? What are these three reagents? These are strong oxidizing agents. Strong oxidizing agent. And these two are mild oxidizing agents. So if you want to use these mild oxidizing agent, then you have to start with aldehyde. Okay. If you use mild oxidizing agent with aldehyde, you can produce carboxylic acid. Okay. But if you want to convert an alcohol to acid, then you have to use strong oxidizing agent. There is no other way. Is it clear to all of you? So this is all about the first preparation of carboxylic acid. So do you have any doubt from this? Shall we go for the second preparation? Shall we go for the second preparation? Okay. The second is from alkyl benzene. Alkyl benzene. So you have to take an alkyl benzene and the vigorous oxidation of this alkyl benzene with chromic acid or KMNO4 with OH will give the carboxylic acid. So let me take one alkyl benzene. Methyl benzene. Methyl group is the alkyl group here which is attached to the benzene ring. So it is called as methyl benzene. So methyl benzene on treatment with KMNO4 and OH minus will give benzoic acid. So what is happening here? The alkyl group is getting converted to acid. Okay, COOH. So instead of this methyl benzene, if I take isopropyl benzene, this group is called as isopropyl. So isopropyl benzene on oxidation will also give carboxylic acid. Okay, it is also getting converted to COOH. Okay, so this group is methyl group and the CH is attached to this ring. So it is called as secondary alkyl group. Okay, so if I have C6H5 attached to CH2CH3, then CH2 is attached to the ring, right? So this is called as primary alkyl group. Okay, methyl, primary alkyl and secondary alkyl. Methyl means CH3 will be there. Primary means CH2 will be attached to the ring. We use a mild oxidizing agent, we will get aldehyde. Then again, if you use the same, is that aldehyde gives a carboxylic acid. Yes, Deva, you can take. You are asking about the mild oxidizing agent with alcohol or aldehyde. Is that aldehyde gives a carboxylic acid or not? Listen. Mild oxidizing agents, what they will do, they will stop up to the aldehyde. They will not further oxidize the aldehyde to acid even if you use it. Okay, are you getting my point? So you can take aldehyde, and you can use the mild oxidizing agent. Okay, it will produce carboxylic acid. Okay, this is possible. But you cannot take alcohol and form acid. If you take alcohol and if you are using mild oxidizing agent, you will get aldehyde. But aldehyde on further treatment with mild oxidizing agent will not produce carboxylic acid. That is not possible. Clear? Clear? Understand? Okay. So what I was saying here, yeah. So the methyl group, primary group and secondary group. So all these three alkyl group containing compounds will react in the same manner to give the benzoic acid. Okay, they all react in the same manner to get the benzoic acid. But the tertiary group containing methyl compounds, the tertiary group containing alkyl compounds will not get oxidized to benzoic acid. Okay. So tertiary group is not affected. Tertiary group containing compound means I can take one of the ring which is attached to C, CH3, CH3 and CH3. So this is a tertiary butyl benzene, right? So here we have only one carbon, no hydrogens are attached to it. So if there are no hydrogens attached to the carbon, which is attached with the phenyl ring, then no oxidation happens and there is no formation of the product. Okay, oxidation will not happen. Tertiary group is not affected. Only primary and secondary and methyl groups are affected to produce the corresponding product. Okay. One more thing is, you can take any alkyl benzene, whether it is methyl or isopropyl or ethyl or any alkyl group. So all of them will end up with benzoic acid only. All of them will give the same product, which is benzoic acid. Okay. If we use aldehyde with strong oxidizing agent, it will produce carboxylic acid only. Okay, carboxylic acid doesn't undergo any oxidation process to give some other product. Okay, so carboxylic acid is the strongest acid. So there is no other oxidized product other than carboxylic acid which is formed. Okay, Parveen? Clear? Okay. So as we are running out of time, students, I am wrapping up the today's session here. So we are discussing the preparations of carboxylic acid. So far we have discussed two preparation. So from the third one onwards, we will discuss in the next class. Okay. Thank you so much. Thank you so much. And I have launched a poll. You can give your answers. And then you can get ready for your next class. Take care. Thank you.